Hello and welcome to Metro AVTechTips. I'm Brent.
I'm Adam.
And it's Wednesday.
It is
and
Wednesday.
I'm still laughing at myself dancing in the intro.
In the intro? Yeah, right? Yeah. Nah, that was the...
I don't know when or where that happened.
Yeah. You can thank Trent for that, for adding that one to the intro. So thanks, Trent, for that one. That was great.
So, Adam, first off, go through the usual intro spiel.
Well, first and foremost, everybody, thank you for joining us today. As always, like, share, subscribe, hit the little bell to let you know whenever we do go live, which, of course, is every Wednesday at 3 p.m., which, of course, it is, and Friday at 3 p.m. as well, where we talk about our tech tips solutions. And, of course, find us on Facebook as well. We should be live there as well. Let me know if you're watching on Facebook. We watch and monitor the chat and everything on there as well. So let me know that you're there, because that'll come through. I don't know where the chat is on Facebook. I still have yet to figure that out. I haven't put any...
Do you use Facebook?
Not really. I'm not on Facebook anymore. I mean, I am. I don't really do.
Have you posted your new toy?
I have posted my new toy
on
Facebook.
By the way, just so everybody knows, if you look up Adam Rogers on Facebook, he's got a brand new red toy that he's very proud of.
I am very happy with it, yes. But more on that.
I would encourage you to look it up and just...
Yeah. So anyways, if you find us on Facebook, go ahead and let us know in the chat or in the comments. We do monitor those as well. And, of course, if you are catching this after the fact, leave your questions or comments about anything that we're talking about today down in the comment section.
Or anything else.
Or anything else at all. We don't even care if it has nothing to do with today's episode. We just love hearing from everybody out there that's watching.
Just tell us we're wonderful.
Yeah, that too. That's helpful as well. So, now, today's topic comes straight from our tech support.
And kind of based on last week's.
Yeah.
Which is what I thought I understood last week, so we got into it.
Yeah.
It took me a while to get it figured out.
You know, once we got it kind of dialed in a little bit.
This one I understand.
Yeah, this one makes sense, and we don't have to dial in too much.
I got a call about this morning, and it's really funny.
Yeah.
How often we get this.
We literally got a call about this like 30 minutes before we went live. Oh, you had another one as well? Okay, so we get this call pretty often about power and distance and how we can make things work. Now, today I wanted to focus specifically on surveillance. But just know that this also applies in pretty much anything else that you do. If you watch last week's episode where we talked about the four staples of a system, four pillars, the fantastic four pillars of system design. Again, I think who was that? Was that Mark?
A young lady.
Or was that?
I think it was a young lady came up with that, wasn't it?
I'm not entirely sure. I'll have to go back and look at the chat.
However, it was awesome.
It was perfect. So thank you so much for that. But again, for today's episode, what we wanted to talk about was power and actual power, and specifically the making sure that you're designing your surveillance system around the idea of making sure that everything has enough power. So, with that being said, I'll go ahead and actually hit the button here to show what today's title is, which is Surveillance Systems and Power. Pretty straightforward.
Which, again, was right before this
30 minutes before, yeah, 30 minutes before today's episode, 30 minutes ago, we got a phone call, and it was specifically about he had a system.
Let's go ahead and start with that.
I was going to say, it kind of feeds into it, right? So let's lay out the scene here, right? Now, I'm going to get a couple things wrong here. We're going to say that I'm getting it wrong because I'm trying to protect the identity of people instead of the fact that I just wasn't paying attention enough to know certain particular things. So, anyways, so the caller had a system that he was putting into a storage facility.
Large commercial facility.
Yep, very large facility. There's many different buildings, strewn throughout the storage facility and whatnot. He also had multiple telephone poles throughout that would have like the big lights on it for like people being able to go in at night. So the problem he had, of course, is that most of the telephone poles were at least 300 feet away.
If not more.
If not more. And so in that case, he was already up to the distance limit of what PoE was going to be able to provide, which is 100 meters. If you go in and look at the distance limitations of PoE, standard, not PoE plus or anything like that, because that actually, depending on how much power you need, you actually winds up getting a little bit shorter. But with just standard PoE plus, or even just standard PoE, you're looking at 100 meters is really the limitation for what you have.
What is the limitation of standard networking?
100 meters. It's essentially the same. So the distance that you're able to go with that is about 100 meters. And
why is that the limit?
Signal loss.
And what do you lose with signal?
You lose
With
current.
signal loss.
Well, you lose. Wait, what?
With signal loss, what are you losing? Why is there signal loss? We're not talking RF, we're talking over copper. So
yeah.
what diminishes over distance?
Voltage,
And
current.
exactly.
Yeah. So because over distance, the truth of the matter is that copper is a really good conductor, but it also has its flaws, right? It's going to add resistance to the line. It's as if you put a resistor inside of the connection there. Let's say you're going a shorter distance and you wanted to mimic the resistance of something like that. You can actually calculate that. If you go online, you can find different calculators and stuff. And in fact, we got a new toy today to play around with and show people a little bit.
Not so much a new toy as an application.
We have a new application for it. So we have our iPad here, and I don't know why it took us this long to figure out that we can tie it into
the Apple TV sitting in the rack.
Exactly. So we have the iPad here tied into it directly. This here, we're just showing the website here. This is just one of the calculator.net things. It's just a voltage drop calculator. So if you go online, you can just do a search for voltage drop calculator. But the nice thing about this is that this actually gives you down here at the bottom, and I apologize for scrolling so quickly. I know some of you are on large screens, but this will give you the resistance per kilometer. So you can see that up here in the top, and we don't have that there. So resistance per kilometer. So if we track that down to the 18 gauge, which is the traditional
power
wire for analog, is traditionally 18 gauge. That's a 21 or 20.95 resistance on an 18 gauge. Now, if you look at category wire, or Cat 5, which is traditionally
22 to 24.
20, yeah. So just say 23. The resistance is a 66.79 ohm resistance.
Basically 67. It's 67
basically
ohms.
67 ohms. Or 67 ohm resistance on that. So that's something to take into consideration when you are messing with
I'm going to scroll back up here.
Yeah, go ahead. You're actually off camera now.
Okay.
Or you're on camera
Because
now.
there's a couple of things on this that I think are very important.
Yeah.
Because when we're talking about power is voltage and current. So let's start with those components.
Right.
Those pillars.
Those pillars.
Of what we're doing.
Yeah.
Voltage and current.
Yep.
How is voltage delivered?
So voltage is pushed from the power supply, correct? Did I get it right? I got it right. What do you know? Hey, I listen, right? It's been what, 3 years?
On the bat.
Something like there, yeah.
At some point, the bat's going to start causing damage.
Yeah, that is true. That is true.
So the voltage is essentially the carrier.
It needs to be a sock filled with oranges. You don't leave any bruises. I'm just...
Just saying.
I'm just saying. No, so yeah, it's the voltage is pushed, the current is drawn. And so, of course, when a device is put on the end of something with a lot of resistance, the current draw is actually increased.
And why is that?
Because it's working harder it's not getting enough.
Distance.
Because it needs to pull enough to get it.
It's like sucking water out of a hose.
Right.
That's current. When you turn the spigot on, that's effectively voltage.
Right.
And you can determine the flow. Is it a gallon a minute? Is it 5 gallons a minute? That could be voltage. Is it 6 volts, 12 volts, 24 volts, 48 volts? And this is a loose analogy. But let's say the voltage is down a little bit, and you get down to the end, it's not a rush, it's a trickle. Now, you can throw a pump on it to try to pull more. And assuming that you can feed it at the other side.
Yep.
But what happens is the further you go, the harder you have to pull on it to get it there.
Right.
Because pressure is dropping in that hose over distance.
Well, and actually, the analogy works really well for water pumping as well, because you have that same problem when you have a pipe system.
Hydraulics and current.
Exactly. They actually will continue to add resistance to it. The actual friction of the fluid moving through the pipe actually creates resistance to that pump, and so it makes it actually really hard for the pump to work over longer and longer distances. So you have to add in additional pieces to help
Anybody that's
expand
done
it.
low voltage lighting outside that was DC knows the last light's dimmer than the first light.
Exactly.
And effectively, and we see the same thing with LEDs, and we've discussed this in the LED episode. So when you're going distance, wire gauge becomes very critical.
Yes.
And you mentioned 18 gauge. So would you pop me back over to
Sure will.
the iPad?
Whoop, there we go.
Now, we've got a simple calculation here. We've got an 18 gauge wire, which is fairly standard in our industry.
Yep.
And we're going to go a mere 100 feet. This is a residential application.
Right.
We're going to draw 1 amp.
Right.
Which is, again, about standard. So we're going to look at loss on this now. And the loss at 100 feet is a little over 10.5%. We are at 1.28 volts.
Yes.
Now,
Or we're losing 1.28.
1.28 volts.
Yes.
Right. Now, let's say that, okay, you know what, I got a box of 16.2 in my truck. Let's see what happens when we switch to 16.2. Same distance, the only thing that's changed is the quantity of copper.
The thickness of the copper, right? It's the gauge of it.
Yep.
So when we calculate the new one,
Now, look at our loss. It is substantially less.
only have a 6.69 drop.
Percent.
Percent, yeah.
Right, so we've actually lost 0.8 volts or less just by going up in gauge.
Right.
What this simply means is when you're doing an installation and you've got to go any kind of distance, and I consider 100 feet a break-even point,
Yep.
go up in wire gauge.
Yes.
Up means larger, not a higher number.
Correct, yeah. And now, can you get away with certain things by doing, like, so say for instance, we only have 18 gauge on the truck. Can we run multiple 18 gauge? Just double it? Yeah.
In fact, if we go to a 14 gauge, or actually 13, which is effectively a 16.4 doubled.
Right. Yeah.
Is a 13. It's not quite 12, but it's better than 14.
Sure.
So same distance with a 13 gauge.
Only a 3.34% drop.
So it keeps, basically each time we double it, it cuts the drop in half.
Right.
Now, as voltage drops, current draw becomes larger because you've still got to get that energy out of it. And, you know, as voltage goes down, current draw goes up. And
Right.
Again, we're only at 100 feet here.
Right.
So, you know, when we talk about this all the time with extending IR, extending audio, or extending speakers, which is why 70 volt AC is so much better for speakers.
Right.
And by the way, don't forget to check out that episode.
Yeah. That one was, we had that one, a year ago.
Year ago.
We had it with...
The guys from True Audio.
That's right, Jimmy and, oh boy, Dave?
The tall guys.
Yeah.
They were
I think it's Jimmy
tall.
and Dave.
I'll believe you.
Mark, maybe.
I think it was Mark. I just remember they were tall.
Yeah, yeah. Really good episode on that. 70 volt systems, we did talk about that.
We also talked about loss
Yeah,
and
we
distance.
did. Yeah, and
So-
AC does help with that problem as well.
In fact, if you actually, I like this at the end of the line voltage. You're at 11.6, which is a negligible variance over 12.
Right.
You go back to the 12, to the 18 gauge, again,
Cut
the
back
industry
over here to the
standard.
back.
You're at under 11. Now, your gear's probably still going to work because most 12 volt items will work down to 9 volts DC.
Correct.
I would not push it because at that point, again, you're pulling more current
Yeah, because it's having to compensate for the low
for the lack of voltage.
Yeah, and so you really, it's not necessarily that it won't work. It'll probably work.
It will last a shorter life.
Yeah, how much longer is it going to?
Because it's breathing harder, it's working harder.
Right. You're breathing through a straw instead of breathing.
And basically, electronics, current is breath for electronics.
Yes. Yeah. So, one of the things that we don't normally talk about, one of the things that we should talk about. when
I
it
like
comes
this. We
to-
don't normally talk about, but should.
So, more of is the fact that when you look at a power supply.
Yes.
And, okay, no, pardon me. Back up. Hand me that camera there, if you would. The one, either one, doesn't matter. Just one. So, when we look at a camera, this is a.
That's a camera.
This is a camera. This is a PoE camera, but specifically, I'm going to talk about the microphone. How about now? That's better. Thank you. I appreciate that.
That's embarrassing.
My microphone, well, probably I was picked up by that one. So I'm going to start over. So we have a camera. One of the things
That's
that
a
we
camera.
don't normally talk about is the power supply for a specific, this power requirements for a device, right?
Well, speak for yourself.
Sure. Well, yeah, we all talk about that a lot, actually.
I like talking
But one thing that
power.
we should talk even more about is that, right? Because we already talked
You
about
have
it
to
a
balance
lot.
your systems out.
But yeah, we really need to understand that. So this camera here, for instance, what we say, it's a PoE camera, but I'm going to talk about the 12 volt power supply that it has on it as well.
By the way, most of our cameras that are IP based also have,
In fact, I believe all of them do.
and there's a good reason for that.
Yeah. So you can
get to
actually
that
power
call.
these. Yeah, you can power these locally at the camera. So what this is here, what our recommendation is of course 12 volt power supply with a minimum 1 amp capability or
Per
1 amp
device.
per camera. In fact, we actually say a little bit, we recommend a little bit higher than that. The minimum is really a 1 amp.
50% headroom.
Right. So when we look at getting a power supply for this camera here, and we need to decide on what type of, how much power should that power supply actually have, should we look at just getting a 12 volt 1 amp power supply? Or what if I only have a 12 volt 5 amp power supply on the truck?
Or 10 amp.
Or a 10 amp.
Or 100 amp.
Will that work?
Absolutely, and why?
So again, we go back to the fact that voltage is pushed or given,
yes,
right, by the power supply, and current is drawn. So this camera is only going to draw the amount of power that it requires for itself.
Right, and if draw goes up on a device, what will cause draw to go up?
So you could have a short. Something could be shorted out, and which means that it's shorting out entirely, so it's going to draw all the power directly through it, and that means that we have a major problem. But luckily, most power supply systems will have like a fuse built directly into them
to stop that from happening.
To stop that from happening, and in some cases, it's per channel.
Now, as the device ages, it becomes less efficient.
Yes, delamination happens.
They start leaking. Caps or resistors start leaking.
Right.
Current draw will go up.
Right.
Environmental conditions, as it heats up outside.
Yes.
Circuit boards become less efficient. Power draw will go up.
Right.
So all this is why you want to have a 50% headroom.
Yes.
Because there's so many things you can't control. By the way, when it's really cold, electronics like that.
Yeah. Well, because everything runs a little bit more efficiently, right?
Yeah.
Everything kind of runs better.
I can tell you the Miata runs a whole lot better when it's cold. Should I be standing over far away?
No, no.
Are you going to vid me?
I don't know if if any of our viewers are from Florida or the Southeast. I don't know if you're aware or not. It's hay fever season.
It's
but
allergy time.
Not only that, there's a super bloom happening right now. A super bloom of pollen and everything else, and so I am.
Is that
all
why my
sorts
black truck is green?
Yeah, pretty much. Yeah, I'm all sorts of screwed up today. So, but I'm here.
Okay, whoa. Today's just like any other day as far as you.
This is true.
Your sinuses are messed up.
Yeah, that's true. So, pardon me for having this here. I just want to make sure I'm not on air dying and hacking.
And coughing and
fur
balls.
And actually this kind of brings up again, hold on. I'm getting ahead of myself. I want to know from you, the viewers, and anybody else who watches this even after the fact, I want to hear from you. What tools do you use when you are designing a system for surveillance or anything else for that matter, if you need just maybe LED lighting systems or whatever else, because DC power over distance is very difficult. AC power is a little bit easier, but you still have to consider that. Yeah, it's AC. Thank you, Nikola Tesla. But I would like to hear from you on what tools or how do you design a system like that?
I have a simple tool for that.
Yeah.
I call Adam.
Sure.
If I'm setting up a system.
Yeah, true.
And you are the Spyclops guy.
One of, yeah.
If I am setting up a system, because I don't know the individual draw on these. I do know it's all in the white papers.
Yep.
I know all that information's there.
Right.
But I'm a lazy guy.
Sure.
So I'm not going to look at that white paper.
Wait, is this hypothetical?
No.
Okay.
No, it's not hypothetical.
I'm just making sure.
Really?
Yeah,
You're going to go down that road?
Yeah.
I'm going to call my tech support. Now, it's not just for surveillance.
Right.
When I'm setting up a rack, I want to make sure that my 110 has sufficient current to support my amplifiers, my AVR, and my processor under load.
Yes.
Now, here's the thing. Under load. When it's dark, and these cameras are outputting IR, and there's high activity happening, the drain on the system is going to be greater.
Yes.
So we're back to headroom.
Yes. Now, and actually, this is a telling factor. That specific scenario is actually a telling factor for the life of the power supply as well. Because over time, a power supply itself can go bad.
Sure, it's just
and they do go bad, right? One of the things that we see, one of the tech support calls that we get, and it's not super common, but it's one of the ones that we get that's a easy tell of what the problem is. We'll get a phone call that says, "Hey, my cameras always are working during the day, but as soon as the nighttime comes around, they stop recording." Well, when they stop recording, if you go back and watch the timeline of what happens, the cameras will flick over to the night vision, and within a couple moments, they will actually stop recording and die out. The system is still recording that channel. but the camera itself has
It's
actually
not outputting video.
it's not outputting video. In some cases, you'll see it actually come back and try again, why does that sound
over and
like
over
again.
HDMI?
Right, exactly. It'll come back and keep trying, and then eventually just won't do anything at all. What's happening is that the power supply itself is no longer outputting enough current to supply enough power to that camera for the night vision LEDs on the camera, because
Particularly
they
if
draw
there's
more.
cameras involved in the system.
Yeah. Now, in fact, we actually had a kit system that went out that had 2 different power supplies on it, both of them 12-volt power supplies. One of them was meant for the cameras, and one of them was meant for the DVR. Now, the DVR only requires 2 to 3 amp
Right,
of
because
power.
it's not doing much work.
It's not doing very much. It has to power the hard drive. It just has to power the on-screen interface, all that kind of stuff, which it still requires some.
Yeah, but it's not working.
Correct. Whereas the cameras themselves, they were actually required closer to 6 or 7 amps of power, and they had a power supply specifically for them. And so sometimes the client would call in and say, hey, the DVR is working fine, but the cameras have stopped working, all of them at the same time. Again, it was something overnight, or maybe something else was happening, but it wasn't giving enough power to the cameras. Maybe it was working fine for a couple cameras, but as soon as a new camera was added to the system, it stopped working.
Events will affect this also. If somebody pulls up into your yard with their headlights on, the cameras are now working harder for the auto iris adjust.
Yes.
So they're going to pull more current.
Yeah. Yeah, and actually we have seen that as well, to where you had a camera that was all set up like that, and as soon as the car came in line and the lights were hitting it, it would start to focus on that or start to change the iris, and then all of a sudden it would short out, and you wouldn't see any recording for a couple seconds. Pardon me. It would die, and then it would
it tapped out until it
came back on. Yeah, what would be the best way to terminalize?
It tapped out and came back.
Yeah, there you go. That's a good way to do it.
Now, I got a call this morning, and I haven't mentioned this one to you, but guy was saying, I have to go further than what I want to go, and it's a 12-volt camera.
Right. Can
I just put a 24-volt power supply on it to give it more voltage?
No.
That was my call.
No.
And tell me why we cannot do that.
So, calculators are great in a perfect world, right? So, in a perfect world, you could calculate and say, at 200 feet or 500 feet, I'm going to lose 12 volts over this type of cabling, and I'm throwing numbers out there. It could be any other number. And in a perfect world, you'll be able to plug in the camera and at that specific distance and get that much power. Now, I
would try to do it with a Variac, but
well, sure, but you may have gotten to that point, and you may have gotten like an especially good run of bulk wire.
And not as much loss.
Not as much loss, and now you fried your camera from that side.
Or the power supply is incorrect on its ratings, and we've seen a lot of those.
Right. And so these are things that you have to consider not doing because of that, because you can...
Well, and you're not smarter in the system. I know you want to be, but you're not.
Well, and the thing is that you can do certain things to help yourself with that, but the truth is that you're going to run into trouble if you do that.
Okay, so we've got this, and it's PoE. So we're going to eschew this and go with the PoE.
Okay.
Now, I've got a nice PoE switcher. I'm plugged into the output of the DVR and VR. At what point am I going too far? And how do I know that?
Again, perfect world, 300 feet or roughly 100 meters. Or 100 meters, roughly 300 feet, right? Perfect world. But again, in most cases, your copper that you have in your category wire, your termination, whatever else it is, it's attenuating that cable even more than just the built-in resistance.
And we're assuming you have bought good category cable.
True. And so, truthfully, you're probably looking at between like 95 and 90 meters.
I think you're optimistic, but we'll go with that.
To ensure that everything's working at that distance.
Now, the nice thing about PoE devices, particularly the new ones, there's a little bit of intelligence involved.
There is.
And they can negotiate, kind of like he did.
It's also at a much higher voltage. So you can see, and actually I'll switch over here really quick to...
Well, I tell you what, let's go back to this a second. Let's go to 24 volts.
So actually PoE, you can get up to 48 or 52 volts on that.
I understand, but we're just going to go from 12 to 48.
Okay.
So we're on the 18-gauge copper where we had a loss of 1.29 volts, I believe. Close enough. Let's see what our loss is. Okay, that at 24 volts is effectively the same.
No. So when you were at 12 volts, you were actually at 10% loss.
Okay.
So
okay.
it's roughly half. And again, by a calculator, it's roughly half.
But that's not the real world.
But that's not the real world. So if we calculate it again, 10.64.
Yes, there we are.
See what I mean?
Yes.
So in the real world, again, if you go up in gauge, or if you go up in voltage, it's close to the calculator, but again, it's not going to be perfect. It's not a perfect world. In fact, in a perfect world, you would have no resistance, and you just plug it in, and you would be fine to go.
By the way, copper does vary depending on how it's processed.
Yes.
And it's measured in microhenries. You can get, if you anneal a piece of copper.
Not a normal size Henry?
No, it's a microhenry.
Microhenry.
Microhenries.
Okay. All right.
If you anneal.
Is there a lot of them running around?
Thousands of them, because they're micros.
Yeah, exactly. Now, can we? No. Okay.
No.
I'm taking the joke a little far. Continue
But they're
on.
not visible.
Yeah.
The advantage of an annealed wire is greater distance, lower resistance.
Sure.
But let's face it, it's expensive, and the vast majority of copper we get nowadays.
Right.
And now we bring in our own stuff, so we're fairly sure. But there's a lot of stuff out there that you buy through distribution that may or may not be up to standard. So as metallurgy varies, the amount of loss will vary because we're not dealing with 100% copper.
Sure.
I was on a conversation with one of our salespeople prior to coming in here. Guy was trying to set up a true AB switching system.
Okay.
And he was thinking, well, we're thinking about using light switches. Well, you can't.
No.
Because light switches, the metallurgy and cheap light switches,
Yes.
is pure unadulterated garbage.
Yes.
You can do it with the solid brass or quality gold-plated blade switches.
Yep.
But light switches?
No.
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 And it's not the fact that it's the light switch, it's the fact of the metallurgy
Right.
of that switch.
It doesn't matter how big it is or anything like that. It's not
just
that it's
garbage metal.
oversized or anything. It's just the metal itself, the metallurgy of it is not
and
great.
all sorts of different materials in it affect the current loss.
Yes.
Which will affect the sound.
Right.
Now, the theory, okay, all amps are going to the same switch, so well, no, because you got multiple switches, and God only knows from switch to switch
Right.
what that mixture is.
Right. So let's change course just a little bit. I know that we wanted today to specifically be about surveillance, but I think what we can do is kind of bring this back to HDMI. Right?
Okay.
It's very easy for us to bring stuff back to HDMI because we're the HDMI people. But let's kind of talk about the fact of how HDMI plays an effect on, or how power plays an effect on HDMI. In fact,
TV.
I want to look at this here. If we change that 48 volts to 5 volts DC, and you change the gauge wire down to what you would see on a 5 volt connection on that.
Yeah, let's go to 32 gauge.
I'll hit this button here to switch us back over to that.
It is unlikely this wire will support 1 amp of current.
At how long? 100 feet.
100 feet.
So,
and by the way, we have sold 100-foot,
yeah,
and effective, very good ones.
Yeah.
But we had a repeater that boosted up the current.
Right, we had active
And
cabling.
stabilized the voltage. So
Change that. Change
okay,
that.
we can't even. It won't even give us the loss
It won't
number.
even. No, it won't even give us that. So let's go ahead and leave it at feet. Let's do this here down to. Actually, let's change this to meters because most of our cables are in meters. We're going to go ahead and put in, just for kicks and giggles, just to get information, a 1 meter drop.
Wow, you're already losing 1 volt on
Yes.
a 1 meter cable.
Yes.
Now, not just voltage, you're losing current.
Yes.
Why is this critical?
Well, because for the most part, there's a requirement for for current to make sure that it works correctly.
And what is that requirement?
You would ask
You
me that.
read it this morning.
55 milliamp.
There you go.
There we go. Got it. I knew it was there somewhere.
Now, that is the base requirement.
Yes.
If you throw any kind of active devices on it, they're pulling more than that. Those devices can easily pull up to 1 amp.
Yes.
Now, up until recently, a good quality 2 meter cable, in the early, we'll go with the early days when we honestly, we were still figuring this out.
Right.
When you looked at a 2 meter cable, it was 28 gauge. Now, we've learned a lot since then, but let's start with 28 gauge.
So would we see a 32 gauge anywhere today?
Oh, absolutely.
Yeah.
Absolutely. We had on the ethereal, on the EHD series, up to 38 gauge,
Oh, wow.
which is a very tiny thin wire, but it was an active cable.
Right.
And it supplemented the TMDS voltage.
Yes.
Now, we had devices like the AIO and splitters and things like that supplement the 5 volt and the hot plug,
Right.
which solve a lot of these issues. So voltage and current, and it's not just for us. DPL, when they're testing cables, they look at how much loss there is, not just in the eye, not just in the rise time, but in the 5 volt and the hot plug, because all that plays into it.
Right. So we have here 28 gauge, which is kind of more of a standard size.
That's
for
a fairly
what we're
standard
using
1
today.
or 2 meter cable.
Right.
Or was.
For so what are we using today for like our MHX?
MHX, I believe, is 28. The MHY, I think, is 30. However, the difference between the two is on the MHY, we're a lot more critical on the windings. Now, timing is also very important
Yes.
in an HDMI cable.
Yes.
And what makes the MHY work with the smaller gauge is the quality of the build of the individual pairs.
Right.
A lot more effort's put into that.
Yeah.
Consequently, you pay more. The MHY is more expensive than the MHX, even though the MHX has more material.
So tell me this: if we have
Riddle me this, Batman?
riddle me this, Batman. Have you seen the new Batman?
No, I haven't.
No,
Have you?
No, I haven't yet either. I'm kind of curious about it.
You just went sideways, but
well,
okay.
I know, but I've heard like mixed reviews, and I didn't know if you had seen
I
it. Or
haven't.
not. No.
I haven't seen the new Spider-Man yet.
Oh, you got to see the new Spider-Man.
I'm told.
New Spider-Man is really good.
I am told it's very good.
Don't spoil it
I'm
for
also
him.
told the new Ghostbusters is very good, and I haven't seen that.
I haven't seen that either. Yeah, I've heard the same thing. Anyways, going back. So, I completely lost my train of thought.
HDMI, voltage and current.
So when power, and this is a problem that we see with HDMI, it's very easily evident on HDMI because it's very easy to touch the head shell.
Yeah, the heat.
The heat. So here's what's happening with the problem when you have something that's overheating. We actually used our video switching system here when we went over to Precise Audio. When we did our on-site video.
With the
And
trucks,
we used...
which is a great video. If you haven't
great
seen
video,
it.
yeah. Go back and watch that one. It was 2 weeks ago?
2 weeks ago.
Yep. So go back and watch that one. Pardon me.
You are going to give me the vid, aren't you?
Well, no, just the super bloom. So one of the problems that we ran into is that after we did the video, and it was great that it didn't take super long for us to do that video, except for the hour and 15 minutes. It was very warm. But the head shell of the HDMI cable itself was very, very hot.
Well, now this, okay, it's important to understand this was a 100+ foot HDMI cable, active fiber.
Yes.
And it was in a very hot environment. In fact, you took a call early about, can I put this in an attic? Now, it wasn't a fire, it wasn't the cable, and I would never put an active head shell and terminate that in an attic. It was a DVR, NVR,
I believe so, yeah. But the truth of the matter is that even just the ambient temperature can have an effect on the equipment itself, even down to something like an HDMI cable connection. But what we learned and what we found out was the fact that this video switcher, this Blackmagic ATEM Mini, it's not outputting enough
It's
power.
drawing a lot of current.
It's drawing a lot of current from that connection. And so the HDMI head shell was getting very hot. We should have used the additional power supply for it, but in the moment of getting everything set up and trying to get things working quickly, we didn't plug it in.
Okay, well, let's take a step back to something that everybody's done.
Sure.
You go to jump a dead battery in a car.
Yep.
If you have less than really good quality jumper cables, and they are less than very solidly connected to the two batteries, they will get very hot.
Yes, they will.
Why are they getting hot?
Well, because it's trying to draw a lot of current over a 12-volt carrier connection through a not so great or a small gauge
Or bad connection.
cable on that.
So it's just
because
not passing it.
You've got one battery that's fully loaded. It's got all the current that it needs. You got one battery that's drawing a lot of current because it's trying to charge itself, and so it's going across that connection. It's going to get hot and just heat up.
And what's the solution?
Better jumper cables.
Bigger gauge.
Bigger gauge. More power.
More power, more power, more power.
More power. More power, baby. Go watch Donut Media. Great guys over there. Donut Media, they do a bunch of car shows and stuff on
Haggerty.
Up to Speed and all that kind of stuff. Really cool guys over there.
I'm the Haggerty Revelations is my favorite.
Oh, okay. So, relating this back to the camera systems and how the designing with the power in mind is why it's so important is because is the camera working? Sure. It's working in the moment. It's working the first couple days, working the first couple weeks, maybe even working in the first couple months.
It will die.
It will die if you are putting that at the maximum distance that it can possibly go. So we've talked about the problems. How do we get around those problems? So, for instance, the gentleman that we opened the show with, who has the large facility and whatnot, and for his layout. Now, all of these telephone poles or light poles have power at them because they have lights on them, right? So he needs to get what's the solution? We'll start
in my
there.
book, a media center, a media converter.
Yeah, media converter.
See, I would do everything over fiber for a couple of reasons. First off, we have no clue how this place is the power setup.
Sure.
We have no clue about the grounding of the power.
Yep.
So if we're actually trying to hard connect these devices with copper,
Yes.
the potential for grounding errors is high.
Yep.
And that could damage the system. And we also are trying to go a long distance. So as you mentioned, a NEMA box at each post. You put a media converter there, fiber in, network out, network in, fiber out.
And yeah, actually backing up what is a media converter? A media converter takes a Ethernet connection, converts it to optical fiber.
Takes an optical connection and converts it back to Ethernet.
Yeah. You would see it as an SFP port on an Ethernet switch. You would also see it as an SFP module sometimes.
And there are standalone media converters.
Yeah, correct.
So that is my answer to that, not just from a power standpoint, but I also worry about grounding potential and noise on the lines.
And that's definitely something to consider as well, because that's going to do that. Now, the system like that's probably one of the the best way to do it, because you have a hard line connection to it, essentially. However, in that case, you have to make sure that you have the ability to have a hard line connection. In his case, he does, because he's actually putting the conduit in place to have it ready for it. However, there is a possibility that you may not have that. Maybe you're coming in after the fact, you're adding additional things, you can't dig it up, you can't do whatever it is. The client doesn't have the money for it. So in cases like that, you can look at instead, one thing that I've seen before done is a point-to-point wireless system.
We've done that for Metra.
Yep. So Ubiquity is one brand out there. There's multiple others out there as well. Luxel used to be one that had it. I don't know if they have it anymore. They have wireless point-to-point transmitters.
And they're high bandwidth, reasonably high bandwidth.
You can get gigabit speeds.
That's reasonably high.
Yeah.
And nowadays, that's not high, it's reasonably high.
Yeah. Pardon me. So,
you know what? I'm in frame. I think I'm going to move out of frame just so you're scaring me.
So one thing that you can also look at, they have point to multi-point systems for that as well. Wireless point to point.
More complex antenna.
Multi-point. Right. So you have one central point, which is probably where the NVR is. Then you have multiple receivers at each one of the telephone poles, which then communicate back to that.
Transmitters.
Yes.
The telephone poles.
Yeah. And so then they all communicate back to the one point, rather than a mesh system, which then everything talks to everything else.
It's going to be less expensive just to deploy that than individual.
Right. Now, the benefit to that is that it is the network. So that does give the client the possibility of expanding that to additional locations, or they can service Wi-Fi to the different locations in other areas out there as well. So if they wanted to give Wi-Fi to their consumers that are storing stuff there for whatever reason, or they wanted to have additional Wi-Fi services devices out there, they can do that as well. And so that does open that up for expansion for the client as well, at the same as the fiber going through the
Conduit.
The conduit. Thank you. To each location as well.
Do it.
Can do it. Can do it.
Now, and as it's off topic but not, we had this discussion about guys doing pre-wires today, putting in conduit to protect themselves in the future for HDMI, particularly as they move to 48.
Yep.
Conduit's a wonderful thing.
Very much so.
Make sure
if you can put conduit in, if you can put conduit in, put conduit in. So I think for the most part, that kind of covers the idea of what I wanted to cover today, unless there was something else that you needed to add to it. But for the most part...
Seriously, if you have any questions on setting up video surveillance, this is not a joke, and I'm not patting you on the back.
Thank you. I appreciate that.
System design is going to be very important once you walk away from the small residential environment.
Right.
So understanding power, call Adam, call Stuart, talk to Luis. Let them help you plan the system out. Because you don't want these things dying. And they will die early.
Yep.
Heat is the enemy. Current draw causes heat. Excessive current draw causes excessive heat. And it will kill your products.
Yes.
So plan early, upgrade your wire gauge. If the system calls for 18 gig for 100 feet, put in 16 if you're going over 100.
Yep.
Better yet, put in 16.4 and double it up.
Yep.
Because it does matter.
It definitely does. So, with that, everybody, when you're putting in power systems, just take those things into consideration. Make sure that you have the distance that you need for it. Make sure that you have the current that you need for it and the resistance.
Now, on our cameras, I do have a question, because again, I'm not the Spyclops guy.
Yeah.
On our camera, as we get further distance down, do they auto-negotiate the correct voltage values?
So they use the standard PoE communication standards. So whatever is built into the PoE switch itself, or whatever the PoE standard uses, essentially what they'll do is they'll say, the PoE will send out we actually talked about this on a PoE episode. It'll send out the first connection to it. The process is it negotiates it and says not enough power, too much power, just right enough power, the Goldilocks thing, and then from there it sends back and says that's good. And
so
then it negotiates back a very slight amount.
EQ levels of voltage.
There's different kinds as well. There's the not so. There's one that's just I'm sending 52 volts,
Good luck.
That's it.
Good luck.
There's ones that will negotiate a very little bit back and forth. Not a lot, but a little bit, and those are there as well. So, but that's essentially what our cameras are doing. There is a negotiation happening to a small extent, not a lot.
Fine tuning.
Yeah, and that's basically it.
Not gross changes, but fine tuning.
Correct. Yeah.
Okay.
Yep. But that's basically it. Cool.
Cool.
All right, everybody.
Well, on that happy note,
Yeah.
join us again on Friday when we'll discuss something based on today's discussion. And oh, look at this!
I have
what
it
are
ready.
we going to discuss on Friday, Adam?
We're going to talk about the Spy DB9. This is our 9-channel, 9-way power distribution
DB9?
box.
Is that a car?
Almost.
Really?
I don't know. Yeah, I don't know.
That's a James Bond car.
Oh, is it? Okay.
DB9.
Yeah, DB9.
Yeah.
I'm trying to make a joke on the spot, but it's not working. So come back Friday. We're going to talk about
missing you
the
being healthy,
Spy
by the way.
DB9. Yeah, I know.
I hope that come Friday you're healthy,
Hopefully. Probably
because it's no fun carrying you.
not. Yeah, I know. So
It's your job to carry me, darn it.
come back on Friday. We're going to talk about the Spy DB9. This is just a 9-way power distribution box.
Now, it can also be used
Pretty
for other
snazzy
things.
piece. It can.
As long as you stay within the 1 amp per output load.
Yes.
And this is rated, I believe, at 1 amp per output?
It's actually 10 amp
Total.
So it's a 9-way, 10
So
amp.
you've got 1 amp per output with a little bit of overage.
Yeah. Yep.
These are also great for powering up LEDs.
Yes, they are. Because it's 12 volt power.
Yep.
So come back on Friday for that. Also, come back next week where we are talking about frame rate.
Frame rate?
Mm-hmm. And why.
What are you framing me for?
Well,
what have I done? What have I not done? What am I getting in trouble for?
We're going to discuss why 60 frames per second movies are weird.
Oh, so you're not framing me.
No.
We're discussing video frame rate.
That's frame Brent.
Frame, yes.
Yeah, we're talking about frame rate.
So it's FPS, not FB.
Yeah, correct, yeah.
You know what FPS is, right?
Yeah, frames per second.
Just checking.
Oh, yeah, no, I'm good.
I'm just checking.
No, yeah.
Because I'm not so sure about you today.
Yeah. RPM,
Really?
sure. Rounds per minute,
Okay, yeah.
revolutions per minute.
Now, I just want to throw this out there. I was very pleased when talking with Adam about his new toy.
Mm-hmm.
What was the first question I asked you?
What's the transmission?
Exactly. And what's the correct answer?
It's a stick.
Yes, it is. I am so thrilled.
It's a stick. My kids will learn stick, and their kids should learn stick as well.
And your wife can drive a stick.
Yeah, she can.
So,
Hey, Stuart. So, everybody, thank you so much for joining us today. Come back next week. We're going to talk about the 60 frames per second and why it's weird.
well, is it specifically about 60 frames? Or we're going to discuss 30 and 24 also.
We're going to discuss those as well, but because not to take away that
I'm not
episode
a
a little
60
bit.
frames per second guy.
No, in fact,
Kind of.
I'm not even a 30. I prefer the 24.
24.
Or 23.95 or whatever it is.
94, I think. Whatever.
Yeah.
And the higher the frame rate, the more freaky it gets to me. It's like cartoons.
Yeah. Now, video games, the higher the frame rate, the better for me.
Well,
But
we've done
movies-
that here.
Right. And movies, though,
When we got a chance to play
Yeah.
with the Xbox here with the 120, it's like, okay, I get it. I get it.
and I think Linus Tech Tips actually did a video on higher frame rates does actually make you better as a gamer.
Really?
Like they tested it.
Let me tell you what can make me better as a gamer.
Nothing.
Not a darn thing.
Everybody, come back next week. We're going to talk about that. Come back the week after that, and I believe we are talking about something that I don't remember. So you'll have to find out next week.
I do know what we're doing in 3 weeks.
What are we doing? Oh yeah.
Oh yeah.
Yeah. So in
Another
3 weeks'
field
time, not a field trip. We're going to stay here.
Oh.
Yeah, because it's not ready yet. It's not ready yet. So, but come back.
Discuss plans and system design.
Yeah, plans and system design. Come back in 3 weeks. We're going to discuss system planning and for an installation. This is actually going to be system planning for an actual installation.
And I believe we have a special guest.
We do. Yep. Actually, a previous employee of Metro.
Our red-headed leprechaun, our 6'4" red-headed leprechaun.
Yeah, sure. Yeah. But come back 3 weeks from now. We're gonna do that episode. It's gonna be a lot of fun. We're gonna use this new iPad connected to the Apple TV to show up on the screen and stuff. So
and isn't it amazing how the simple things amaze him?
I'm just excited about it. Look, when things actually work. I mean, look.
I know you didn't point at me when you said that.
It's just there. I just put it up on the screen. It's there. It's good to go. Look, see, I can flip back and forth.
Ooh, I'm gonna.
I know. I'm sorry, everybody, for doing that to you. Yeah. I apologize.
In that case, I'm Brent.
I'm Adam.
Reboot early.
Reboot often.
Turn off CEC.
Don't cut your wires too short.
Call tech support and have a great day.
We'll
there was another one we wanted to add. What was it? Because we were talking about how long the closeout was getting.
Don't put your HD base T has to be at least 20 meters.
That's it. Do not make your category cable shorter than 66 feet.
That's too long. It just needs to be 20 meters. Make sure it's 20
and
meters.
How long is 20 meters?
It's 66 point whatever feet. But the point is that
too short to kill you.
HDMI extensions need to be
60 plus feet.
Over category wire need to be at least 60 plus feet.
And if it's Cat 6, maybe 75.
Maybe 75. Everybody, thank you so much for watching. We'll see y'all next time if I hit this button correctly here, and we'll see you then. Good night.